Today's video will explain what a design description view is, how to interpret it, and how to create one. Hello, I'm James Helfrich. One of the most important design tools we have is the design description, and this is a collection of views, each of them describing a different aspect of a software design. So the question is, what exactly is a view? How do you interpret one when you read it? And how do you create your own views when you're trying to describe software to another audience? So what is a design description? So a design description consists of many different views. Each view is a different perspective on the overall system we're trying to design. The design view has a design information. This is a table which explains the different components of the view, but it also has a design representation. And this can be a class diagram or a component diagram, or pseudocode or flowchart or something like that. Now, each design representation conforms to a viewpoint, and a viewpoint governs a design representation. In other words, not just anything counts as a class diagram, it has to conform to the rules specified by the UML organization. Now, a viewpoint frames many different design concerns. For an example, a class diagram would frame how to represent data in the system, whereas a flowchart represents how the algorithm is going to function, or a data flow diagram will frame the design concern of how data flows through the system. Now, a viewpoint defines many elements. For an example, a class diagram would have the plus or the minus or the tilde describing different access modifiers, or a flowchart would have the decision diamond or the I/O parallelogram. And these are all design elements that consist of a viewpoint, and the viewpoint governs the design representation. A requirement is something the client needs. It could be specified as a formal requirement or a user story in many different ways. And a design information refers to many different requirements. In other words, a class diagram for an address class is going to represent how an address is stored in the system. Presumably, there's going to be a requirement saying that an address is stored in the system. And a design concern describes many different requirements. The design views section is a collection of views, each of which is a perspective on the system. Each view has two parts, the design representation and the design information. Now, like I mentioned before, the design representation is going to conform to one of many different viewpoints, like a component diagram or a class diagram, a data flow diagram. The set of design viewpoints you're going to need for your application depends upon the needs of your application, obviously. For an example, if your application requires a database, then it's probably going to have one or more entity relationship views that are governed by that viewpoint. And every different view is also going to have a design information, naming the view, describing what requirements it utilizes, describing the elements or subcomponents of it, as well as what viewpoint it conforms to. For an example, take a look at this view. We have a mobile client, a web portal, and a server has a subcomponent of a business logic and a database. If you look at this by itself, you have many unanswered questions. The design information will help us understand it. First of all, it's going to give us a name and a number for this view. This is the system view. Its purpose, describe the overall system. A description, the basic client-server architecture, where there are two flavors of clients, the mobile and web. Okay, now I understand what this is all about. What requirements does this help build? Requirements 1.0 through 2.9. Okay, I'd like to know more about business logic or database. Well, the elements to say business logic is access control, account management, etc. Okay, that's helpful. And the database is a SQL database containing all client data. Okay, now I can understand what this is representing. If it's referenced by means there's a view that references this one. So this is the top level view that will be empty on that one. And what kind of viewpoint is this? It is a component diagram. This whole thing together, both the design representation and the design information together represent a single view. Now, here's another view. I'm going to call this a view 2.4, and it looks to be a class diagram. Its name is elements. Its purpose to describe how the game elements are in memory. A description and inheritance hierarchy of the various game elements. The requirements section is also filled out. And notice that each individual class referenced this has a name, element, position, stationary, inertial, and has a subview corresponding to it. For an example, if I look at inertial 2.4.5, that's going to reference another view, and next to it 2.4.5 is going to be the inertial class. And this inertial class is going to zoom in on that inertial, which is just named in 2.4, but now flushed out in 2.4.5. So we're providing more information when we zoom in. Now, also take a look at this design information for 2.4.5. We have the reference by. It's referenced by 2.4, which is elements. In other words, every view points to its parent view, unless if you're the high-level view, and every subview points to another view which elaborates on that in more detail. So in other words, we have kind of a doubly linked list going on here, or an array tree. So I can always zoom down by looking at the sub-element, sum-element, and I can zoom up by looking at the reference by, and reference by. You can learn more about this in the Design Views section of the Design Descriptions chapter of the Software Design textbook.